Okay, today we are doing 4.5, Chapter 4, Section 5, Writing a Function Rule. So, as you can see up here, we're trying to, many real worlds have a functional relationship, can be represented by equations, and we're going to use an equation to find a solution of a given real world problem. Here's our first example. We're going to write a function rule. All that means is writing an equation. If you read this, problem 1, writing a function rule about insects, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents the situation? So you can estimate the temperature. If you look here, it's saying the temperature T is equal to this distance here. So that's all you have to do. T equals, because these two distances, like I said, are equal. T equals 1/4 N, and the temperature is about 40, so you add 40 to the 1/4 N. That's it. That's the equation. Moving on. A landfill has 50,000 tons of waste in it. Each month it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after M months? So the landfill already has 50,000 tons of waste. So we want to know here the total, we want to know the total amount of waste after M months. So we can use T for total amount. So in our problem here, it's going to be T equals the 420. Remember, they told us to use M for months right there. So we're going to have 420 M, and then we just add the 50,000 tons that was already in the landfill. So every month they're adding 420 more tons. They started with 50,000. That's all you have to do to write a function rule. Remember, each month an average of 420. If you have that each or per, that tells you where the variable goes. Next slide. Carolyn has 420 CDs in her collection. Each month, she adds 12 more CDs to her collection. What equation is a function rule that represents this situation? So she has 420 to start with. Each month, she adds 12 more. So because it says each or per, in this case, each month, that's where our variable is going to go. So we could do T for total CDs again. And M for month. So what we get is T equals, she's adding 12 more per month, so 12M, and she started with 420 CDs. There's your function rule. No big deal. Okay, now you've got this beast. Let's read it. Problem 2, writing and evaluating a function rule. So now we're going to write the equation, plug in a number, and get a solution. So this one says, writing a function rule and evaluating, as I said, writing the equation and plugging a value in. We're talking about concert revenue. A concert seating plan is shown below. Reserved seating is sold out. total revenue from tickets will depend on the number of general seating tickets sold. Write a function rule to represent this situation. What is the maximum possible total revenue? So up here it says reserve seating is sold out. So we got to figure out how much money they made with this reserve seating right here. So if reserve seating costs $25, they have 10 rows, 12 seats per row. 10 times 12 is 120. So we're going to do 25 times 120. Let me bring up the graphing calculator. So we're going to multiply 25 times 120. And we get $3,000. Because the reserve seating is sold out, $3,000 represents the income they've made thus far. General seating is $10 per row. They have 30 rows at 16 seats per row. So 10t, right? You can see here, again, these two distances are equal, so we can set them equal to one another. So we're going to use R for total revenue. We know that it's $10 per ticket. We have the 30,000, or 3,000, sorry. We have the 3,000. So that's our equation. Let's go back and read the problem again so we make sure we answer the question. So what is the maximum possible total revenue? We're going to take this 30 times the 16 and plug it in for the n, because that'll tell us the maximum revenue. So 30 times 16, 480 general admission seats. So we wrote the equation up here. Now we're going to plug in the 480 from the graphing calculator. So you have R equals 10 times n, or 10 times 480. Plus the 3,000 they already made for the reserve seats. And then all you have to do is multiply 10 times 480, which is 4,800, plus the 3,000 they've already made. So that's a total revenue of $7,800. Don't forget that dollar sign, otherwise you lose a half point. Good idea to read these kind of sidebar things over here. They said add the reserve seating to the revenue to get the total revenue. So reserve seating was at $3,000, $10 per ticket for the general, 480 total seats, 4,800 times the 3,000, a total profit of $7,800. Okay, so we have a similar example here. A kennel charges $15 per day. Again, we saw that per or each. That means you're going to have a variable. We could use D for day. So we want to know the total cost, N. So let me read the whole problem. A kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost N days of boarding plus a bath. How much does a 10-day stay cost? So N days of boarding plus a bath. So that bath, which costs the $12 here, that's a one-time. They don't have to give the dog a bath every single day, just when they come in to the boarding kennel. So our equation here, we want to know the total cost N it's $12 per day, or sorry, it's $15 per day, plus the $12 for the flea bath, and they want us to calculate how much a 10-day cost, how much is a 10-day and a 5-day. The first thing they want us to do is the 10-day cost, so we'll plug in 10 for the D days, so 15 times 10 plus the 12, N is going to equal 15 times 10 is $150 plus the 12. So N equals $162. That's how much a 10-day kennel visit would cost. They also asked us here to compare the cost of a 5-day and a 10-day stay, and they want to know if it costs half as much. So let's check that out. We have 15D plus 12, just rewriting the equation. So we have N equals 15 times 5 plus 12. Then you just multiply the 15 and 5. 15 times 5 is 75 plus 12, which is going to equal $87. So they asked us, does a 5-day stay cost half as much as a 10-day stay? So if we do $162 divided by $87, we can determine if it costs half as much. So it costs a little less than half as much. Let's look at it the opposite way. 87 divided by 162, right? Actually costs a little more than half as much because it's 0.53. If we round this, or if we change from a decimal to a percent, you move the decimal place 2 to the right. So it's about 53%. And they ask us to explain that. It's because of the $12 stay, or $12 flea bath, because you still pay the same $12 whether you stay for 5 or 10 days over here. So that's going to increase the average cost per day because you're adding the $12 to the 5 times 15 or 75. So that $12 is going to cost more as a percentage. Okay? So because of the flea bath, the per day cost for a 5-day kennel stay will be more. That's a good thing to write down because they ask us to explain, so you need to write something to explain that. So because of the $12 flea bath, the cost per day, the cost per day will be greater for a $5 stay. And I just want to show you how the math works for that. So if we go back to the graphing calculator, I'm going to clear it out. We have $87 divided by 5 because it was a 5-day stay. So you end up paying $17.40 per day. Whereas with 162, we're going to do 162 divided by 10. Hopefully many of you can do that in your head because all you have to do is move the decimal 1 over. So when you stay 10 days, your average cost is $16.2 per day. day. Okay? So that's a pretty detailed explanation to why it costs more, but it's pretty easy to figure out the cost per day and then compare those two numbers. It's going to cost more per day at $17.40 when you say 5 days as opposed to $16.20 for 10 days. All right. This example says an archery club charges an annual membership fee of $65 plus $2 per visit. Write a function rule for the total cost of belonging to the club if you make V visits in a year. How much would it cost if you use the club 15 times in a year? So that 15 is what we're going to plug in at the very end. But let's write the equation. Again, we have that word per or each. So one-time membership fee of $65. They want us to use V for visits. So we can also use C for cost. So C equals cost. V equals visits. And now we can write our equation. So we get C equals, again, $2 per visit. So V for visit, so 2V plus the $65 for the annual membership fee. And now all they want us to do is plug in the 15 into the equation to see how much it would cost if you only visited the club 15 times in a year. So 2 times 15 plus the 65. So C equals 30 plus 65. So C equals $95. So that's the total cost if you visit the club, which is what they're asking. How much would it cost if you use the club 15 times in a year? That would be a poor investment to make in an athletic club. Hopefully you go 3-4 times a week and more like 150 to 200 times per year. Okay, moving on. We're going to write a function rule for the area of a rectangle. So as soon as you see area of a rectangle, we're going to draw a rectangle. And write a function rule for the area of a rectangle whose length is 5 more than the width. So width is W. We're doing area, so think about what the formula for area of a rectangle is. That is area equals length times width. So if the area of the rectangle whose length is 5 more than its width, all you have to do for the length here is W plus 5. What is the area of a rectangle when the width is 9? So we can plug in our length here is W plus 5. The width is W. So we can plug into our equation here. So area equals, our length is W plus 5 times W here. Now, this, to me, looks strange. I like to write the W in front of the parenthesis, so I'm just going to switch the order. So W times W plus 5. And then they tell us that the width is 9 feet. So they want us to say what the area is going to be with the width being 9 feet. So I'm going to plug in the 9 for both of those W's. And it looks like that. Remember PEMDAS, the order of operations. You have to do parentheses before you multiply the 9 in front. So we get area equals 9 times 45. So we'll go back to the graphing calculator, clear it out, and multiply 9 times 45, and we get 405. area equals 405. And remember, we need the units here. So we're in feet, mentioned twice in the problem. And you want to think, is area feet squared, or feet cubed? Area is feet squared. The way I remember that is I'm multiplying two dimensions, length and width. That's what tells me it's feet squared. So if we're doing length times width times height to get a volume, the squared would change to a cubed because we have three dimensions. So two dimensions, length and width, feet squared. If you're doing volume, three dimensions, feet cubed. Okay, so we've got two more examples, and then I'll let you loose on the homework. We're going to write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. What is the area of a triangle when the length of its base is 16 inches? So, write a function rule. So area of a triangle, that means you have to know the formula for area of a triangle. I like writing it as 1/2 base times height. Others sometimes prefer to write it as base times height divided by 2. Either one's fine. You'll get the same result. So the height is a dotted line that goes from the base directly vertical, creating perpendicular lines between the base and the height. They say a triangle's height is 4 more than twice the length of its base. So 2b, twice the length of the base, we're multiplying the base times 2. And it's 4 more than, so more than means addition. So 2b plus 4. That's the equation for the height. So if we don't know what the base is, because the height is 4 more than twice the length of its base, that means the base is just b for base. Okay? So when we write the formula, all we have to do, we're going to plug the b in where the b is, and the 2b plus 4 where the h is. So I'll show you what I mean down here. So area equals 1/2. The b does not change, but 2b plus 4 does change. So they tell us that the base is 16 inches. So we're going to plug that 16 in for both of these b's. So 1/2 times 16. If it helps you to understand to put the 16 over 1, do so. Remember, when you multiply these fractions, you multiply straight across, top and bottom. We're going to continue to plug in. So 2 times 16 plus 4. So that's order of operations fun. If we multiply straight across top and bottom, we get 16 over 2. 2 times 16 is 32 plus 4. Now we'll continue to simplify. So area equals 16 divided by 2 is 8. 32 plus 4 is 36. And to be safe, we'll plug that into the graphing calculator and make sure we get the correct multiplication. So 288 is the area. I'm going to scroll back up to the problem to check my units. So the units here, they're talking about inches. So because we have two dimensions again, we have the base and the height, it's going to be inches squared. Okay, so if we look at letter B here, says graph the function rule from problem 3. How do you know the function is nonlinear? So if we have, I'm going to take our original equation before I plugged anything in and manipulate that equation so we can see if it'll be linear or nonlinear. So I can take this entire term and distribute it into the parentheses. So all I do when I look at 2 times 1/2, I just think about what's a half of 2? Well, that's 1. What's b times b? You get 1b squared. Just like x times x is x squared, b times b is b squared. So I just multiplied these two. Then we have 1/2 b times 4. So again, I think, what's half of b, or half of 4? That's 2. So we get area equals b squared plus 2b. Anytime you have a squared, it's going to make this graph into a parabola. I'm just going to show you on the graphing calculator so you can see b squared plus 2b. I'm going to plug that in. I'm just going to use x instead. That's what the calculator understands. Then we're going to look at what that graph looks like. So clearly nonlinear. This is a parabola. So if we look at the table of values, that's what's going to happen with our table of values. So I'm just going to copy this back to the page we were working on and make sure we get the correct ordered pairs. So we're going to make our x, y table. And I'm going to go ahead and change those b's to x's. That'll make more sense to graph. And then remember we have x comma y like we did from the previous section. And we're going to plug in, there's no point in plugging in 0, so I'm going to plug in 1, 2, and 3. So when I plug in 1, I get 1 times 1 squared plus 2 times 1. I'm actually going to solve below so you can see what happens. So 1 squared is 1. 1 times 1, still 1. 2 times 1 is 2. So when I plug in 1, I get 3. Just like our ordered pairs say right here. So when I plug in 2, I should get 8. So I'm going to plug in 2 here. So I have 1 times 2 squared plus 2 times 2. Okay, now we'll do the math here. So 2 squared is 4. Times 1 is still 4. 2 times 2 is not 2, 4. So when I plug in 2, I get 8. So let's plug in 3. We get 1 times 3 squared plus 2 times 3. 3 squared is 9. 9 times 1, still 9, plus 2 times 3, which is 6. So when we plug in 3, we get 15. So you may notice here that all of our values are positive. So if we could look back at our graph, so 1, 3, 2, 8, and 3, 15. I'm going to try to look back at the graph. So we just got 1, 3 about right here. We got 2, 8 about here, and 3, 15, which is off the graph. So you may remember when I was telling you how to graph the absolute value, and yesterday when I told you, or on Tuesday, when I taught you how to graph x cubed and x squared, that it's a good idea to plug in negative values as well, because in this case we only got half of the parabola. So we have to plug in, we're going to plug in -1, -2, and -3 to get some more ordered pairs so we can graph our parabola more accurately. So I'm going to go back here. I'm actually going to copy the top of the chart to a new page so I have some more room. And we'll plug in -3. So the 1 doesn't do anything, so I'm no longer going to write it. But make sure, when you plug in negative or positive number, use parentheses, because if you don't, you'll end up with the incorrect answer. So -3 squared means -3 times -3. Remember, the exponent tells you how many times you need to multiply the base. So -3 times -3 is 9. 2 times 3 is -6. So I'm actually going to take my plus away and just write -6. So when I plug in -3, I get +3. And if we go back and look at the graph, that makes sense. So if I plug in -3, I get +3. I'm going to plug in -2. So -2 squared plus 2 times -2. -2, comma, -1. Or I don't know why I wrote -1. Let's do the math on that. So -2 squared is 4. 2 times -2 is -4. So when I plug in -2, I get 0. Again, we'll look back at the graph. When I plug in -2, I get 0, that point right here. Now when I plug in -1, I should get -1. So let's do that. -1, so I get -1 squared plus 2 times -1. -1 squared is 1. 2 times -1 is -2. 1 minus 2 is -1. So when I plug in -1, I get -1. Really important. I just want to show you on the graphing calculator what happens. We'll plug this one in using parentheses versus not using parentheses. So we'll show you the incorrect way first. -3 squared plus 2 times -3. Incorrect answer, -15. Then I'm going to add in the parentheses around the negative. And the reason you get the incorrect answer, I'll show you in a second. I'm going to insert a parenthesis here. Oops. And insert the negative. Let's try that again. So parenthesis, -3 squared plus 2 times -3. We get our proper answer, 3. Okay? Just to make it even more simplistic, if I do -5 squared, what's your guess? What am I going to get? -25, as opposed to -5 squared, then I get +25. So for getting parentheses, your answer is 50 off. So don't forget the parentheses, please. Okay. And if we were to graph that, we're going to end up with our beautiful parabola here. And that is it. Your homework is posted on Schoology. Tomorrow, Friday, or depending if it's second or first period, on Friday you'll be working on a worksheet with these topics. So make sure you're paying attention so you know what you're doing. All right? So you've got the rest of the block period to work on the homework. Friday, you'll have a worksheet involving the same topics, and have a great day.